in this example, we're going to deconstruct a regular square pyramid. So this is a pyramid that has a square for the base, as its name would suggest. Okay, so we're just going to define a few things. A base edge is side length of the base. So in this case, that would be MN would be one of those, or NO, or OP, or MP, or PM, whatever you want to call that. All those four are base edges. Now, lateral edges, that's different than the slant height. A lateral edge is these edges of the triangles up here. So that would be like QM and, well, let's leave it orange actually. That'd be like QM and QO and QN and QP. All of those would be lateral edges. Okay, the apothem of the base. Well, let's talk about the slant height actually. So slant height here, remember that's the height of a triangle. So that would be QX, QX. And the apothem of the base actually ends up making this nice right triangle with the slant height and the altitude of the pyramid. So let's actually say the altitude of the pyramid is QY, right? That's when we talk about this is, remember slant height is L and altitude, that's H when we're talking about surface area or volume of the prism, or sorry, of the pyramid. And the apothem of the base makes this nice right triangle with the slant height and the height. And in this case, that's XY. Okay, so let's maybe work some stuff out, see if we could find some of these lengths. Given MP is 16, so MP is 16, and QX is 10. Let's find QY, QP, MO, and YP. All right, I'm gonna work in green. So QY is the height. And for a square pyramid, it's maybe pretty intuitive to see that the apothem, remember the apothem is just half the height or half of a side length. So if the side length of our square is 16, then we can say with pretty good confidence that the apothem is half of that, or 8. So then to find QY, well, now I have this right triangle. So QY, 8 squared plus QY squared equals 10 squared. And actually, now that I'm looking at this, it looks like a 3, 4, 5 right triangle, right? Where this is 4 times 2, and this is 3 times 2, and this is 5 times 2. So then QY would be 6. I feel pretty good calling QY 6. If you want to work out the Pythagorean theorem, you'll find that to be true. Okay, QP. QP is this lateral edge right here. And let's see, this is a square, so we know that this length XP right here is also half of, because we have the apothem, it's half of the side length, so that's 8. So we had 8 for XP and 10 for QX. So now, actually, let's maybe work in a different color for this one. So for this problem, we'll just work in pink. Okay, so we've got 8 here and 10 here, so that means 8 squared plus 10 squared, my two legs, equals QP squared. So we can solve for QP. 164 equals QP squared. And let's see, 164. Well, we're taking the square root of both sides here, right? So just trying to think through what it would look like to take the square root of 164 and simplify that. 164, we'll just write here, 164 breaks down into 4 times 51, I think. No, that's not, can't be right. 4 times 41. There we go. So then that would be QP would be 2 times the square root of 41. 2 root 41. Yeah, great. And okay, MO. Okay, MO now is, we do a color like this. Let's show up. Sure. So MO is this diagonal right here. Please. Okay, sure. It's that diagonal through the triangle. And remember, this is a square. So the diagonal of a square makes a 45, 45, 90 triangle. We already know that one of those side lengths is 16. So then that means that MO would just be 16 root 2. And again, you could, this is a right triangle. This is a right triangle. So you could use the Pythagorean theorem if you're not remembering your trig ratios or your, I guess maybe your special right triangles. But here we can remember we've got a 45, 45, 90. So the legs are each x and the hypotenuse is x root 2. Last but not least, let's find YP. YP. So one last color. They kind of all start to look the same after a little while, but we're going from the center here, and we've created another triangle, right? If you were to extend this, then that would just create the diagonal again. So that's a right angle in here. And again, we have a nice 45, 45, 90 triangle. Trick is now we have the hypotenuse. So we know that for YP, 16 is equal to, this is x square root 2. Well, let's, a few too far, sorry about that. Okay. So 16 is equal to x root 2 because of this 45, 45, 90 triangle. Meaning that 16 root 2 equals 2x, or 8 root 2 equals x. So then YP is 8 root 2. So doing that, we deconstructed kind of a lot of these individual parts of a regular square pyramid. Now that we have all that, let's go ahead and find, and this is going to be a little tricky because my figure won't be on the screen, but maybe, yeah, maybe your figure or whatever you drew will be. Let's find the lateral area. Now remember the lateral area, I guess we can kind of reuse some colors here. The lateral area, that's the sum of the triangle areas. Or we have this nice formula that's 1/2 times the slant height times the perimeter of the base. Okay, so you could find the area of each triangle, or we could use our formula. We found the slant height. Slant height was actually given to us as 10. And the perimeter of our square is 4 sides of 16. So let's just write that out. 1/2 times the slant height, 10, times my perimeter, 4 times 16. Okay, so then that's 5. Well, yeah. So 1/2 times 10 is 5 times 4 times 16, which is 20 times 16, which is 320. So that's 320 units squared. And we don't have units, so we don't have to worry about it. Okay, the total area is the lateral area plus the area of the base. So the area of the base is, remember for a square, it's just side squared. So total area, I know I don't have a lot of room here. Total area is lateral area. Maybe we can, some exciting stuff here. It's lateral area. Okay, one more time. Lateral area plus the area of our base, which in this case is 320 plus 16 squared, which is 320 plus 256. Finally, which equals 576. So my total area then would be 576 units squared. So we've got the surface area, we've got the lateral area, we've got the total surface area. Let's find the volume. Remember the volume is 1/3 times the area of the base times the height. We know that the area of the base, we just found it, was 16 squared, or 256. And the height was given to us, I believe. Or maybe we found it. We found the height, QY, to be 6. So 1/3 times 256 times 6. Oops. Times 6. Now let's make it easier on ourselves. 1/3 times 6. Oh my gosh. 1/3 times 6 is 2. So then 256 times 2 is 512 units cubed. So that's the volume of the pyramid. I hope this video helped you kind of break apart and work with and just get comfortable with working with a square pyramid.